All right, our last section, our last unit we're going to be looking at has to do with systems of equation. Now, a system of equations really means two or more equations, right? So two or more. So not just one equation, two, maybe three, but most of the time it's going to be two. A system means there's a bunch of different things, like the circulatory system would be your veins, your heart, your arteries, capillaries, right? The nervous system has your nerves, has your brain, has the brain stem, the different part. Okay, so systems means it's got two or more parts. Okay, so let's think about some of these things. When we talk about a linear means line, right? A linear equation in one variable, well, that has one answer. So in other words, it only has one variable. For example, like this. How about 2x plus 1 is equal to 13, right? We've seen these equations before. Now, that's just an equation. I know how I'm going to go minus 1, divide by 2, divide by 2. I know that the answer is 6. That's it. That's the only answer. There's not like two or three different answers, right? If it's linear, if it has the exponent 1 here, and it does, this thing means it only has one answer, okay? So what if you have a linear equation in two variables? So it's going to be like x and y, right? So that's actually has, this one has an infinite number of xy points. Oh yeah, right? So that's why we graph these things. So here we go. So therefore, we graph them. Yeah, so it's not just one answer. It's going to be a whole bunch of points, right? And we figure out the slope and the rise and the run and all that, and we put all these points together, and we're going to get a straight line. So that's what a linear equation in two variables, right? If it's got x and y. Remember, we said like y is equal to x plus 5 or something like that. There's an infinite number of x and y points that work. So instead of just one answer, this one has an infinite number, and we connect the dots. So a system of linear equations is really going to be two or more. Usually we'll just do two. Two or more equations in two variables, right? Two variables, two vars. So there's both x's and y's. So what is the answer? Well, seeing as there's an infinite number of x and y points that work for one and an infinite number that work for the other, it's going to be where do they cross? What's the one point? What's the x and y point that works for both of them? Yeah, the answer is an xy point. And remember, it's got to be an x and y point. It's not just like x equal to something. No. It's an x and y coordinate point. And it's common to both. So in other words, it works for both equations. Okay, so let's give this a shot. Here's one equation here. X plus y is equal to 3. And I'll just make up some numbers. I don't know, I'll go like 1, 2, 3, 4, right? You can make up anything you want, right? So so if x is 1, 1 plus y's got to be 2, right? What if I say x is equal to 2? 2 plus something, oh, this has got to be 1. 3 plus something is, okay, yeah, this has got to be 0. And you know what? I can see a pattern here. Because I put these in a pattern, these should also come out in a pattern. I bet you this one's negative 1. Yeah, because it's 4 plus negative 1. That makes, exactly. So there's a bunch of x and y points. I just made those up. I don't know if there's a right or wrong, but I know that there's an infinite number of x and y points that are going to work. Okay, well, let's use the same values. 1, 2, 3, 4, right? So if the x value is 1, I get 5 times 1. So in other words, I get 5 minus y is equal to 15. I can solve this. Minus off 5 from both sides. Again, I get minus y is equal to positive 10, which means positive y is negative 10. Negative 10. It's not the same point. 1 comma 2, 1 comma negative 10. Okay, so that's not the answer. Okay, let's try again. If the x value is 2. Okay, 5 times 2. So this is going to be 10 minus y is equal to 15. You know what? It might have been easier to just rearrange this equation. Oh yeah, remember that? See the y? Move it over to the right-hand side. Y. And see the 15? Move it over here. So I'm going to get 5x minus 15. See, it's faster to rearrange the y. Okay, so now let's actually plug in 2. So 10 minus 15 negative 5. Okay, now let's plug in 3. 15 minus 15, 0. Now let's plug in 4. So it's going to be 20 minus 15, which is 5. But hang on, look at it. There it is. 3 comma 0, 3 comma 0. It's the same point. So this is the exact same x and y point for both equations. So this is the answer. Yeah, when the x value is 4, I get negative 1. Here I get 5. I get two different points. This is the point 4, 5. This is the point 4, negative. These are two different points, but this is the same answer. So that means that the answer is 3 comma 0 is the answer. That's the solution, right? So when it asks you to solve a system, that means for these two equations, find the one point that's common to both. Now, I got lucky here because I just made up these numbers, right? What if it was like a million where they hit? I'm not going to just guess that randomly. So I just got lucky, but I know that 3030 is the same. It's the only one. You're not going to get more than one. Okay, so there's an infinite number of ordered pairs that satisfy. So in other words, it means that they work each equation. Right? So if I wanted x and y points, 1 comma 2 works, 2 1 works, 3 0, 4 1, right? Think about it. Any two numbers that add up to 3, it could be 100 and negative 97. That would work, right? Or it could be a million and negative 999,990, whatever. So there's an infinite number of ordered pairs that satisfy the equation. But, okay, so let's put this on here. But only one satisfies both equations. But only one satisfies, or let's say is common. So in other words, it works for both equations. And that's the big thing. It has to work with both equations because it's a system. There's more than one. I know that there's lots of points that work over here, but it's got to work in both of them, right? The point 1 comma 2 is not the same point over here, so that's not it. So I'm looking for the one point. Okay, so how about this one? It says, is this point 19 comma negative 6? Is this a solution to the system? I don't know. In other words, when I plug in my x and y value, it should work in both. Well, let's try it. Here we go. So 2 times x is 19, minus 5 times y is negative 6, is equal to 68. Is it? I don't know. Maybe it's equal to 68. Maybe it's not. So 2 times 19 is 38. Minus times minus is plus. So plus 5 times 6 is 30. Hey, that does make 68. 68 is equal to 68. Yep. Ta-da! It works. Hang on. It works in this equation. Does it work in this equation? It has to work in both. Okay, so let's take 19, plug it into here. Okay, so 5 times 19 plus 6 times negative 6 is negative there. Is that equal to 58? Well, I don't know. Well, hang on. 5 times 19, that's going to be 95. And then this is plus times minus, so that's going to be take away 36. Hang on. 95 take away 36. When I go 15 take away, I got to carry the one. This becomes an 8. This becomes 9. This becomes, oh, no, that's equal to 58. This is equal to 59. Now, it's really, really close, but no. So it doesn't work for this equation. It's really close, but it's not exact. This is 59. This is 58. They're not equal to each other. So it is not the solution. How do I know? Well, as soon as it doesn't work in one of the equations, that means it doesn't work for this one. And it's got to work for both. Remember, oh yeah, because in order to be a solution, it must be both. Must be both. It has to work in both equations. And you know what? Quite often it'll work in the first one, not in the second one. So what if I hadn't even done this one? What if I had to just started over here? As soon as I get no, I don't even have to do this one because I know that the answer is not the solution. It's got to work in both. So for some of these questions, if they'll ask you to verify, basically that means take your x and y point and show that it works in both equations. Basically, I'm doing this, right? I'm showing that, hey, it's the same point. It works in both equations. Now, how did we get the point 19 comma negative 6? Well, it was just randomly given to us. That's not always going to be the case. So here's what we're going to do. we're going to graph these things. We know how to graph lines, but you graph one line and you graph the other line and you're just looking for where do they cross. So that's all we're doing here. So we're going to graph this system to solve it. So I don't know how to graph this line. Yes, you do. Isolate y. Remember? Remember? Oh yeah, y equals mx plus b is probably the easiest way of graphing a line. I mean, there is also the y minus y1 is equal to the slope mx minus x1. There's all that stuff, but that's not this form. Let's just isolate y. So in other words, the 4x moves over. This becomes negative 4x. The 3 is going to move over. This becomes minus 3. Okay, so I know that this thing has a slope is minus 4, and the y-intercept is minus 3. Okay, well, let's graph that. Okay, so 1, 2, 3. There's my y-intercept, and it's got a slope of negative 4. Now, that's negative 4 over 1, which means it's going up in this direction. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over, okay, it's going to be off the graph, or 1, 2, 3, 4 over 1. Okay, so I can kind of see this thing. I don't have a very good line. It's kind of terrible. But you get the idea, and that's why I put the nice big dots here, so you can see those are dead on points. Okay, let's do this other one over here. Oh, how about we do this one in a different color? We'll do this one in, not red. Red stands out too much. How about purple? Okay, there we go. Let's do purple. Same thing. It's easiest if I isolate y, so let's move this over and move that over. You know what? This is already a minus 2y. Why don't we move the y over? Because that'll make it positive. Okay, so look, I got x plus 12 is equal to, so plus 2y plus 2y, positive 2y. So really, I just want to go divide by 2, I just want to divide everything by 2. Okay, so here we go. What do we get? We got y is equal to 1/2 x, slope is a half, plus 12 divided by 2 is 6. So in other words, this thing starts at 6, and there's your slope. The slope is positive a half. Okay, let's start at 6. 1, 2, 3, 4, 5, 6. Okay, and it's a positive slope, which means it goes this way. I'm going to go up 1 over 2. I'm running out of room. Down 1, there it is. Down 1 over 2, down 1 over 2, down 1 over 2. I can see the point already. Okay, so that's a terrible graph. But you get the idea. There's the point where they cross, and the point is dead on. Now, for some of these, if it's not dead on, all you can do is estimate it. So you're going to have to guess. But this one is dead on, right? Because I went down 1 over 2. Yep, it's dead on. So what are the coordinates here? The x value is negative 2. 1, 2, 3, 4. The y value is positive 5. So make sure you answer the question. Here's the answer. So the solution is actually this. It's the x and y value. So the x value is negative 2, and the y value is positive 5. So that's the solution. Quite often a question like this is going to be worth 3 marks. Okay, so basically 1 mark for getting this correct line, 1 mark for getting this correct line. And then a lot of people forget to actually answer the question. This isn't the answer. This is the answer. Really what some people do is they say, there's my solution right there, right? There it is. But you still need to give it as an x and y point. Okay, so that's the actual answer. The answer is not just x equal to, it's x and y. So it's an x and y point. So that's why we're doing graphing. So we graph these 2 lines, and they should intersect. And they should intersect at 1 point. Okay, so these questions on page 378, these are good ones to start with. I think the first one, they actually want you to look at it, but I think these ones, only the last ones are where you're actually graphing it. This one, I think they want you to plug in a number. So they're not that bad to try. And yeah, these graphs, if you can do them on graph paper, or even like mine wasn't a fantastic graph, but if you do it pretty small, they're usually pretty accurate, and they'll try and get it to intersect right dead on a point. Alrighty, so this is the first part of the section. And this should take us this week and next week, really. Okay, anyways, good luck with these, and take care.